Hello wonderful person, this is Anton, and in today's video we're going to be talking about our own galaxy, the Milky Way. We're going to discuss some of the more interesting facts and pieces of knowledge that we may have not been aware of, and we're going to discuss some of the really cool things about our own galaxy. Welcome to What the Math. Now for this video, I think I'm going to be using mostly Universe Sandbox²2, but we're going to use Space Engine just a little bit as well. And here, we're going to just basically talk about various facts that you may have not been aware of. The first fact is actually, I'm going to recreate using this particular galaxy right here by adding two supermassive black holes to represent two galaxies that are very close to our own Milky Way. Now this right here is Small Magellanic Cloud, and this right here is Large Magellanic Cloud. And the first fact is this: what you may have not been aware of is that our galaxy is actually not entirely flat. It is a flat-looking galaxy, but it does have two bulges that I'm going to try to create right here by having these black holes that are quite massive actually pass relatively close to the Milky Way. And there we go. You can see there's a bulge forming right here, and there's another bulge forming right here. These bulges are actually real. Maybe not as massive and not as pronounced as I've created here, but they do exist. And these bulges are formed because there are two smaller galaxies orbiting very close to the Milky Way, and they basically create this kind of a formation warping our own galaxy. This is a little bit too extreme, but it does look something similar to this. Now, the next fact is about the dark matter present in our galaxy. Scientists today believe that there is actually a very large halo that you can kind of maybe see right here around our galaxy that is entirely made up of the elusive dark matter, the material that we don't really know what it is, we don't really know what it's made of, but we know that it exists because if it wasn't there, our galaxy would have actually not been able to maintain its shape. So the dark matter makes up to about 90% of the total mass of the galaxy. I'm going to actually add maybe a little bit more just so we can kind of tell some of it apart. I don't know if it's going to work, but let's just add a bunch of it until the simulation really slows down. So there's a lot of dark matter around this galaxy right now, and this is essentially the so-called halo that is around our Milky Way at all times. Every single galaxy we've seen so far has these halos, and we've even seen the interaction between various galaxies and their halos as well, especially when the galaxies collide. And interestingly, some galaxies seem to actually have up to about 99% of dark matter, with only 1% of visible matter that you see right here. So the halo is there, even though we can't really see it. Now there is a little supernova going on right now. That's because the simulation is actually called supernova in the galaxy. But what I really wanted to mention in the next fact is the fact that we actually have so many different stars in our galaxy. The recent estimate puts this at about 400 billion stars in total. So in this chunk right here, in this galaxy, the Milky Way, there's like 400 billion stars. That is quite a big number. That is more stars in the entire galaxy than there is grains of sand on the entire planet Earth. If you were to walk around Earth and collect every single grain of sand, you would still not have enough to basically count all of the stars in this galaxy. So that's essentially how many stars we think there is, at least by today's estimates. Anyway, let's go to the next fact, and that's the fact that, as you can see in Space Engine right here, our galaxy is actually very dusty and has up to about 15% of dust and gas that just kind of floats around without really being a star, without being anything else. As a matter of fact, one of the reasons we can't really see the central region very well is because it's actually covered by a lot of this interstellar dust. So even though our galaxy is about 100,000 light years across, we can only really see about 6,000 light years into the disk because most of it is essentially just covered by dust, and we need to use infrared telescopes to see the rest of the galaxy. But luckily, infrared light passes through this dust, so we can usually use infrared telescopes to try to see the rest of a galaxy and estimate its size and of course its structure as well. Now, the thing about our galaxy is that it was actually created from the collision of smaller galaxies, and this is what I'm trying to recreate here. The galaxy Milky Way, as well as Andromeda Galaxy, have all been created from the collisions of these smaller galaxies over the billions of years. So as a matter of fact, our galaxy was much smaller before. I'm gonna try this again. This didn't really work very well. So let's try to collide these, I think 7 or 8 smaller galaxies and try to create one large mega galaxy if we can. So essentially, over the period of billions of years, smaller galaxies collided into one big galaxy that today we know as the Milky Way. And in the next few billion years, we'll also receive a collision from a small Magellanic Cloud and large Magellanic Cloud, and of course the Andromeda Galaxy as well. Meaning that we'll eventually create some kind of a mega massive galaxy that will be dominating the local region on the local cluster of galaxies. So let's see if we can actually have these galaxies collide with each other to create one massive super galaxy as well. And so after about 2 billion years, it seems like we've been able to combine all of our supermassive black holes into one, and now this galaxy will actually stabilize and become its own massive circular or possibly elliptical galaxy. And this is essentially what happened to our own galaxy as well. Now, speaking of, the way that our galaxy looks and the way that it's portrayed in the media usually, we think that our galaxy looks this way, but every time you see a picture of this is actually not real. We are located right around here. We cannot possibly see the galaxy from the outside. Everything you see so far in the media, on all of those websites you may visit related to space sciences, always show you the artistic rendition of our galaxy, or possibly show you the Andromeda Galaxy. It's not the real representation of the Milky Way, because we can't see it. We only see it from the side, from within it. Just a little clarification. Anyway, so let's move on. The other thing we know for a fact is that one day we're going to collide with the Andromeda Galaxy that you see right here, and this is the Milky Way. And about 4.5 billion years later, they will actually collide in a very spectacular fashion. We might not be around to see it, but it will happen. And when it happens, they'll combine into one major elliptical or possibly spiral galaxy, and they will become the biggest galaxy in the region. So here is this event unfolding and happening in somewhat real time, although accelerated dramatically. The thing is, even though you see a lot of things combining, almost not a single star, or actually very likely not a single star, will collide with another. There will be no stellar collisions, there will be no planetary collisions, and I've actually talked about this in one of the previous videos where I did the math and explained why none of these stars will collide with each other. The collisions are extremely rare. For a collision to occur, these galaxies would have to be at least 10 times larger and have at least 10 times more stars for at least one collision to occur. As it is though, there will be no collisions, they will just kind of combine into one, and in this case, maybe none. Maybe they'll just kind of destroy each other. That's at least in this particular simulation. In reality though, we think it will very likely combine into one massive galaxy that will most likely be known as Milkdromeda. And this Milkdromeda will of course still stay a member of other galaxies known as the local cluster. Now, our own local cluster contains approximately 50 or so galaxies near us or within the vicinity of us, including some of the larger ones like Andromeda and some of the smaller ones like the small Magellanic Cloud. But for the most part, all of these galaxies are always kind of together, and this is what we call the local cluster. But if we were to zoom out dramatically, we would realize that we also are a part of something much larger known as Virgo supercluster, and that is a part of even something larger known as Laniakea, which is our local supercluster, also known as the Greater Supercluster and Laniakea. And this is essentially something that we've talked about previously, and something that I think I'm not going to mention here because we're just talking about the Milky Way. And one of the last things I wanted to mention is the fact that, well, like everything else in our universe, Milky Way is obviously moving. And it currently moves at about 600 kilometers per second in relation to the background radiation, and it moves toward the Andromeda Galaxy. And obviously on top of that, our own solar system, our own sun moves around the central black hole, and our Earth spins around the sun. So the speeds involved are quite dramatic, and this suggests that nothing in our universe is ever standing. It's always moving somewhere. And of course, our sun itself also orbits around the supermassive black hole, and it takes it about 200 million years to orbit once. Meaning that in the entire lifetime of our galaxy, which is about just over 13 billion years old, or just a little bit younger than the entire universe, our sun has orbited it approximately 25 times. And during those 25 times, it may have actually come really close to the central supermassive black hole, and it might have even been on the outskirts as well. Anyway, so that's really all I wanted to say and talk about in this video. I just wanted to mention these interesting facts about the Milky Way and things that you may have actually not known before. And hopefully you learned something from this video. And if you still haven't subscribed, don't forget to click that subscribe button right now, and possibly consider sharing this video with your friends who might enjoy these videos as well. And also, don't forget to come back tomorrow, because there's going to be a lot more educational videos coming, and you might learn something else tomorrow. And anyway, thank you so much for watching, guys. Space out. See you later. Get me later. Bye-bye. And I just destroyed our sun once again and created this beautiful red supernova. It was totally worth it. Anyway, see you later.